Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Zed's new edit prediction feature, powered by their open source model, Zeta. It's incredibly cool.
Yeah, I saw that. Tab to accept predictions? That sounds amazing for productivity. But how does it handle conflicts with existing tab functionality, like indentation?
That's a great question. They cleverly integrated it. If you have language server suggestions, you use Option or Alt to preview the prediction, then Tab to accept. It's seamless. On Linux, they use Alt Carol as a fallback, which is pretty smart.
Clever indeed. So Zeta itself, what's the tech behind it?
It's based on QN 2.5 Coder 7b and fully open source, even the dataset. They're encouraging community contributions, which is fantastic, but they're carefully reviewing submissions to ensure safety and privacy, which is a responsible approach.
I see. And the training process, that sounds fascinating. They mentioned a fill-in-the-middle approach wasn't ideal for edit prediction. Why's that?
Right. Most models are trained to fill gaps, but Zeta predicts edits anywhere in the code. They found models aren't great at granular edits, but they're amazing at rewriting larger chunks. So they trained Zeta to rewrite snippets around the cursor, incorporating predictions.
Interesting. So how did they test such a thing? Unit tests seem tricky with LLMs, right?
Exactly. They used a larger LLM, Claude, to evaluate Zeta's edits. Instead of strict assertions, they wrote tests in plain English, letting Claude check if the results matched the intent. Much more practical than brittle token-level checks.
That's a brilliant workaround. They also mentioned prompt engineering challenges, right? Initially using a 32B model?
Yeah, initially they used QN 2.5 Coder 32B, but it was too slow, and the prompt engineering became a nightmare. Changing the prompt to pass some tests broke others. It was flaky.
So they switched to supervised fine-tuning?
Yes, using Unsloth and Lowray. They started with synthetic data generated by Claude, then collected real-world examples from their team. But even with 400 examples, they hit edge cases.
And that's where direct preference optimization, DPO, came in?
Precisely. DPO let them provide both positive and negative examples, teaching Zeta what edits to avoid. Just 150 carefully chosen examples significantly improved things.
Impressive. But latency is crucial for a feature like this. How did they achieve such low latency?
They used speculative decoding, parallelizing token generation by using the input as a reference. And for serving, they partnered with Bayesian, who optimized the model for their infrastructure. They also use Cloudflare workers for proximity to the user.
Wow, that's a comprehensive approach. It sounds like a remarkable engineering feat. They're even open sourcing the model and dataset.
Absolutely. It's a testament to their commitment to open source. They're planning more experiments too, which is exciting. And they have a companion video explaining the technical details. Definitely check it out.
I will. Thanks for breaking this down. This is a fantastic example of innovative AI application in software development.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.